The year is 1943. Deep within the proving grounds of the German Wehrmacht, a group of the Third Reich's finest weapons engineers gathers around a firing range. Before them sits a rifle that, by all accounts, should not exist. The Americans, whom German military doctrine has long dismissed as mechanically unsophisticated, have somehow created a semi-automatic infantry rifle that works with startling consistency. The weapon is the M1 Garand, and on this cold morning in occupied Europe, German engineers are about to conduct tests that will shatter their assumptions about American industrial capability. The rifle gleams under the winter sun as technicians load clip after clip, firing thousands of rounds through mud, dust, and freezing temperatures. They submerge it in water. They drop it from heights that would disable most weapons. They fire it until the barrel glows red. And to their growing consternation, the M1 Garand continues to function with a reliability that makes their own semi-automatic rifle, the Gewehr 43, seem almost primitive by comparison. This is the story of how the finest engineering minds of Nazi Germany came face to face with a weapon that exposed the fatal flaws in their own design philosophy. It is a story of engineering pride confronting harsh reality, of military necessity clashing with industrial limitations, and of how one rifle came to symbolize the vast industrial and technological gulf between the Axis and Allied powers during the Second World War. To understand the magnitude of what German engineers discovered when they tested the captured Garand, we must first journey back to the years before the war, to a time when nations across the globe wrestled with a fundamental question that would shape the future of infantry combat. The question was simple to ask, but devilishly difficult to answer. Could a semi-automatic rifle truly replace the bolt-action weapons that had dominated battlefields since the late 19th century? Throughout the 1920s and 30s, military establishments in every major power debated this issue with an intensity that bordered on religious fervor. Traditional military minds argued that soldiers would waste ammunition if given semi-automatic weapons, that the mechanisms would prove too fragile for battlefield conditions, and that the added complexity was not worth the marginal increase in firepower. Progressive thinkers countered that the nation which first fielded a reliable semi-automatic rifle to its infantry would possess an overwhelming tactical advantage. In the United States, a Canadian-born designer named Gewehr Garand was working to settle this debate once and for all. Garand had immigrated to America as a young man and had found employment at the Springfield Armory in Massachusetts, where he devoted himself to solving the mechanical puzzles that had stymied semi-automatic rifle design for decades. The challenges were formidable. A semi-automatic rifle had to harness the energy of firing to cycle the action, extract the spent cartridge, load a fresh round, and cock the firing mechanism, all while maintaining accuracy and reliability under the harshest conditions imaginable. Garand worked with monastic dedication, testing design after design, each iteration bringing him closer to a solution. His breakthrough came with a gas-operated system that tapped propellant gases from a port in the barrel, using this energy to drive a long piston that cycled the action. The system was elegant in its simplicity and robust in its execution. By 1936, after years of testing and refinement, the United States Army officially adopted Garand's design as the rifle, caliber .30, M1. It was a decision that would echo across the battlefields of the coming war. Meanwhile, across the Atlantic, German weapons development was following a different path. The Treaty of Versailles had imposed severe restrictions on German military development after the First World War, forcing designers to work in secrecy or to conduct their research abroad. When the Nazis rose to power and openly defied these restrictions, German weapons designers found themselves playing catch-up in areas where they had once led the world. German doctrine in the years leading up to war emphasized the squad automatic weapon, typically the G43 machine gun, as the primary source of infantry firepower. Riflemen were equipped with the Carabiner 98K, a bolt-action rifle derived from designs that dated back to 1898. It was an excellent weapon of its type, accurate and reliable, but it required the soldier to manually work the bolt after each shot. Against an enemy equipped with semi-automatic rifles, German infantrymen would find themselves at a severe disadvantage in rate of fire. The German military establishment was not blind to this problem. Designers like the Walther firm had been experimenting with semi-automatic rifles since the 1930s. The result of these efforts was the Gewehr 41, introduced in 1941. The G41 used an unusual gas system that required no hole to be drilled in the barrel. Instead, it trapped propellant gases at the muzzle and redirected them backward to cycle the action. On paper, this seemed clever. In practice, it was a disaster. The G41 was heavy, cumbersome, and prone to fouling. The muzzle trap system collected carbon and debris, causing frequent malfunctions. Soldiers who received the weapon quickly learned to distrust it. Field reports flooded back to German ordnance departments, describing a weapon that failed at critical moments, that was difficult to maintain under field conditions, and that offered little practical advantage over the bolt-action rifles it was meant to replace. It is at this point in our story that captured American weapons begin appearing in German testing facilities. As American forces engage German units in North Africa, and later in Sicily and Italy, soldiers from both sides scavenge enemy equipment. Some items are kept as souvenirs. Others are sent back to ordnance testing centers where engineers can examine enemy technology. Among these captured items are M1 Garand rifles, and when German engineers first examine them closely, they are forced to confront an uncomfortable truth. The testing begins with standard procedures. German technicians disassemble the Garand, examining each component, noting the materials used, the precision of the machining, the tolerances between moving parts. They measure and photograph. They create detailed technical drawings. And as they work, a picture emerges of a weapon that embodies a completely different design philosophy than their own troubled G41. Where the G41 is complex, the Garand is straightforward. Where the G41 uses an unconventional gas system that seemed innovative but proved problematic, the Garand employs a proven gas-operated piston system that is both effective and maintainable. The Garand's action is machined to tolerances that allow it to function reliably even when dirty, while the G41 requires near-perfect conditions to operate properly. The engineers proceed to firing tests. They fire the Garand under ideal conditions first, establishing baseline performance. The rifle performs flawlessly. They fire hundreds of rounds in rapid succession. The weapon continues to function. They then begin the punishment tests, the trials designed to find the breaking point of any mechanical system. They coat the rifle in mud and fire it without cleaning. The Garand continues to cycle. They immerse it in sandy water, shake it out, and fire again. The mechanism works. They expose it to freezing temperatures that would cause lesser weapons to seize. The Garand fires. They test it in extreme heat. They drop it onto hard surfaces. They abuse it in ways that would quickly disable the G41. And through it all, the American rifle continues to perform, with a consistency that the German engineers find both impressive and deeply troubling. One of the test reports from this period, later captured by Allied forces, contains a passage that is remarkable for its candor. The German engineer writes that the M1 Garand represents a triumph of practical design over theoretical cleverness. He notes that American engineers have clearly prioritized reliability and manufacturability over novelty. The report acknowledges that the Garand's 8-round en-bloc clip system, while having some tactical limitations, is mechanically sound and allows for rapid reloading. Most damning of all, the report concludes that the Garand is superior to the G41 in virtually every practical measure. This admission does not come easily. German engineering pride, particularly in the Nazi era, is bound up with notions of racial and cultural superiority. The idea that American designers, working in a nation that German propaganda consistently portrays as decadent and technically backward, have created a better weapon strikes at the heart of these assumptions. Yet the evidence is undeniable. The numbers do not lie. The Garand works where the G41 fails. The German response to these findings is to accelerate work on a replacement for the troubled G41. The result is the Gewehr 43, introduced in 1943. The new rifle abandons the problematic muzzle trap gas system of its predecessor and adopts a more conventional approach, using a gas port drilled into the barrel similar to Soviet designs. The G43 represents a significant improvement over the G41, but it arrives at a time when German industrial capacity is already strained by the demands of a multi-front war. The G43 is not a bad rifle. Under ideal conditions, it performs adequately. It is more reliable than the G41, more accurate at range than the Garand, and it uses a detachable box magazine rather than the Garand's N-block clip, which some see as an advantage. German snipers, in particular, find the G43 useful when fitted with optical sights, but the weapon still suffers from issues that American designers solved years earlier. The G43 is difficult to manufacture. It requires machining processes and materials that are in increasingly short supply as the war turns against Germany. Quality control becomes a serious problem as production is dispersed to multiple factories to avoid Allied bombing. Some G43 rifles leaving the factory are excellent weapons. Others are plagued by issues from the moment they are issued to troops. This inconsistency is the antithesis of what the M1 Garand represents. German engineers continue to test captured Garands throughout the war, and with each examination, the same conclusions emerge. The American rifle is designed for mass production. Its components are robust and forgiving of minor variations in manufacturing tolerances. It can be assembled by workers with moderate skills and still function reliably. It is, in short, a weapon designed by engineers who understood that a rifle must work not in laboratory conditions, but in the hands of ordinary soldiers under extraordinary stress. Further testing reveals another advantage that the Garand possesses, one that is perhaps even more significant than its mechanical reliability. The rifle is ergonomically superior to the G43. It balances well. The controls fall naturally under the shooter's hands. The sights are intuitive. A soldier can be trained to use the Garand effectively in less time than it takes to master the more complex G43. In the calculus of modern warfare, where armies must rapidly train millions of men, this difference is enormous. Reports from the Eastern Front provide additional context to the German evaluation of semi-automatic rifles. Soviet forces are equipped with the SVT-40, another semi-automatic design that, like the G43, shows promise but suffers from reliability issues in the brutal conditions of the Russian winter and the dusty summers of the steppes. German soldiers who fight against American units in Italy and France consistently report that the faster rate of fire provided by the Garand gives American infantry a significant edge in firefights. A German squad, armed primarily with bolt-action rifles and a few G43s, can be quickly suppressed by American riflemen, all of whom carry semi-automatic weapons. The psychological impact of facing an enemy where every soldier can fire as rapidly as you can work a bolt action is considerable. German after-action reports describe the American infantry's ability to lay down sustained fire that pins down attackers and provides cover for maneuver. The Garand's distinctive metallic ping, as the empty N-block clip is ejected, becomes a sound that German soldiers learn to recognize and respect, even as American troops debate whether this audible signal of an empty rifle is a tactical disadvantage. As 1944 progresses and the Allies advance on all fronts, German weapons testing facilities continue their work, but now with an air of desperation. Engineers examine not just the Garand, but the entire spectrum of American military equipment, and a troubling pattern emerges. American weapons are generally not as technically sophisticated as their German counterparts on paper, but they are invariably more reliable, easier to produce, and better suited to the realities of mass warfare. The contrast in design philosophies becomes stark. German engineers have created magnificent weapons like the MG42 machine gun, the Tiger tank, and the Me-262 jet fighter. These are technological marvels, each representing the cutting edge of what is possible. But they are also complex, expensive, and difficult to produce in sufficient quantities. American equipment, by contrast, embodies a philosophy of good enough. The Sherman tank is inferior to the Tiger in a direct engagement, but America produces tens of thousands of Shermans, while Germany struggles to build hundreds of Tigers. The Garand may not be the most advanced rifle theoretically possible, but it is the most advanced rifle that can be reliably produced in the millions and still function flawlessly. There are documented cases of German units being equipped with captured American weapons, including Garands, when their own equipment proves inadequate. This represents a remarkable admission of the superiority of enemy equipment. German soldiers who use captured Garands in combat report favorably on the weapon's performance, though ammunition supply for the American .30-06 cartridge is always a limiting factor. Some German reports from late in the war describe units that prefer almost any captured Allied weapon to the standard German issue equivalents, a morale disaster that reflects the declining quality of German war production. The story of John Garand himself provides an interesting counterpoint to the German experience. Garand never becomes wealthy from his invention. He is a salaried employee of the Springfield Armory, and the rifle that bears his name and changes the face of infantry combat earns him no royalties. He is motivated not by profit, but by the satisfaction of solving a complex engineering problem. This stands in contrast to the German weapons industry, where private firms like Walther, Mauser, and others compete for contracts and patents, sometimes allowing commercial considerations to override military necessity. By 1945, as Germany collapses under the weight of Allied advances from east and west, the production of G43 rifles has become increasingly erratic. Factories are bombed. Supply chains are disrupted. Quality control is non-existent. Some of the last G43 rifles produced are barely functional, assembled from whatever materials are available, often by slave labor working in underground facilities. Meanwhile, American factories continue to turn out Garands with assembly line efficiency. By the war's end, the United States has produced approximately 5.5 million M1 Garand rifles. Germany has produced fewer than 400,000 G43s, and the quality of these weapons varies dramatically. The technical reports compiled by German engineers during their testing of captured Garands survive the war. Allied intelligence teams find these documents in abandoned testing facilities and military archives. Reading these reports today, one is struck by their honesty. The German engineers, whatever their political affiliations, are professionals who accurately assess what they see. They do not allow ideology to cloud their technical judgment. Their conclusion is unambiguous. The Americans have created a superior semi-automatic rifle, and Germany does not have the industrial capacity or the time to create an equivalent. The implications of this admission extend far beyond the specific comparison of two rifles. What the German engineers are really acknowledging is that the Allies have achieved a level of industrial sophistication and production efficiency that the Axis powers cannot match. The same factors that make the Garand superior to the G43 also make American aircraft, vehicles, and artillery superior in the aggregate to their German counterparts. It is not that German designers lack skill or knowledge. It is that American industry has mastered the art of producing reliable, effective weapons at a scale that overwhelms German capacity. General George Patton famously calls the M1 Garand the greatest battle implement ever devised. While this is hyperbole typical of Patton's rhetorical style, it reflects a truth that German engineers confirm through their testing. The Garand gives American infantry a significant tactical advantage. It allows an American soldier to deliver accurate fire at a rate that a German soldier with a bolt-action rifle cannot match. In the chaos of combat, this difference saves lives and wins engagements. The Garand serves American forces not only through the Second World War, but also in Korea, where it again proves its worth in the harsh conditions of that conflict. It remains in frontline service until the early 1960s, when it is finally replaced by the M14, itself essentially an updated Garand with a larger magazine and select fire capability. Even after its retirement from American military service, the Garand continues to be used by allied nations around the world. Its reliability and effectiveness ensure its longevity. The G43, by contrast, disappears from frontline service almost immediately after the war. Some rifles are used by East German forces in the early post-war period, but the weapon is quickly phased out in favor of Soviet designs. The G43 becomes a collector's item, valued for its relative rarity and its place in the history of German weapons development, but it is not remembered as a particularly successful design. It represents a road not taken, a weapon that arrived too late and performed too inconsistently to make a significant impact. Modern historians examining the weapons development programs of the Second World War often point to the Garand as a case study in effective military procurement. The United States Army identified a need for a semi-automatic rifle in the years when such a decision was still controversial. The Army supported Garand's development work through years of testing and refinement. When problems arose, they were addressed systematically. When the rifle was finally adopted, the infrastructure for mass production was carefully planned and implemented. This stands in stark contrast to the German pattern of rushing weapons into production before they are fully developed, then attempting to fix problems in the field. The testing of the captured Garand by German engineers also reveals something about the nature of technological progress in wartime. Innovation is not simply a matter of having brilliant designers or advanced theoretical knowledge. It requires an industrial base capable of translating designs into reliable products at scale. It requires a willingness to prioritize practical effectiveness over theoretical sophistication. It requires quality control systems that ensure consistency across millions of units. America possesses all of these elements. Germany, particularly as the war progresses, possesses none of them in sufficient measure. There is also a human element to this story that should not be overlooked. The German engineers who test the Garand and write those candid reports are caught in an impossible situation. They serve a regime that demands technical miracles, but lacks the resources to achieve them. They are asked to create weapons that can turn the tide of a war that is already lost. Their honest assessments of American technical superiority must be carefully worded to avoid accusations of defeatism. Some of these engineers are true believers in the Nazi cause. Others are simply professionals trying to do their jobs in an increasingly chaotic environment. But all of them must confront the evidence before them. The Allies are winning not just through numbers, but through superior design and production methods. The story of the Garand versus the G43 is ultimately a story about systems competing against systems. The Garand emerges from a system that values reliability, manufacturability, and practical effectiveness. The G43 emerges from a system that values technical innovation, but lacks the industrial depth to implement it successfully. The Garand is designed to be used by millions of soldiers in every climate and condition. The G43 is designed to be an excellent rifle, but is produced in an environment where excellence cannot be consistently achieved. After the war, American weapons designers study captured German equipment with the same thoroughness that Germans applied to captured American weapons. They find much to admire. The MG42 machine gun influences post-war American machine gun design. The Germans' pioneering work in assault rifles leads to similar developments in American small arms. But these American designers also note the German tendency to over-engineer, to create weapons that are superb in ideal conditions, but fragile when those conditions are not met. This lesson reinforces the American design philosophy that produced the Garand. Create weapons that work every time, in every place, for every soldier. The contrast between the two rifles and the two design philosophies they represent offers insights that extend beyond military history into broader questions about engineering, manufacturing, and innovation. The best design on paper is not always the best design in practice. Theoretical sophistication must be balanced against practical reliability. The ability to produce one perfect example means nothing if you cannot produce a million examples that all work nearly as well. These lessons, learned in the crucible of global warfare, continue to shape military procurement decisions to this day. John Garand, the quiet Canadian immigrant who devoted his life to solving a complex mechanical problem, creates something that outlasts the Reich, that dismisses American technical capability. The German engineers, for all their skill and knowledge, cannot create an equivalent because they work within a system that lacks the industrial foundation to support their efforts. This is not a failure of German engineering, but a failure of the system within which those engineers must operate. As we reflect on this history, we must acknowledge the strange irony at its heart. The German engineers are correct in their assessment. The Garand is superior to the G43 in reliability, manufacturability, and practical effectiveness. But this admission comes too late and changes too little. By the time German testing confirms what American soldiers already know, the outcome of the war is no longer in doubt. The industrial might that produces millions of reliable Garands also produces the ships, planes, tanks, and munitions that overwhelm the Axis powers. The rifle is a symbol of a larger reality. Today, both the Garand and the G43 are sought after by collectors and historians. The Garand is valued for its role in American military history and for its continued excellence as a target rifle. The G43 is prized for its rarity and its place in the evolution of German weapons design. But when collectors fire these weapons side by side, the same differences that German engineers noted in 1943 remain apparent. The Garand works with a reliability that seems almost effortless. The G43 works well when properly maintained, but requires more care and attention. Even decades later, the design philosophies that shaped these weapons continue to determine their performance. The broader lesson of this history extends into the present day. Military planners still grapple with the balance between cutting-edge technology and reliable, mass-producible equipment. The temptation to pursue the theoretically optimal solution remains strong. But the example of the Garand reminds us that the weapon that works every time is more valuable than the weapon that works perfectly some of the time. The rifle that can be produced in millions is more strategically important than the rifle that exists in hundreds. These are lessons written in the test reports of German engineers who set aside their preconceptions and honestly assessed what they saw. The M1 Garand stands as a monument to a particular approach to military technology, one that values practical reliability over theoretical perfection, that designs for the real conditions of mass warfare rather than ideal testing environments. The German engineers who tested captured Garands understood this. Their reports, buried in archives and later recovered by Allied forces, tell a story of professional respect for a well-designed tool, even when that tool comes from an enemy's hands. In acknowledging the superiority of the American rifle, these engineers were acknowledging the superiority of the industrial and design systems that created it. This is the story of how a rifle designed in Massachusetts humbled the finest weapons engineers of the Third Reich. It is a story of engineering excellence, meeting the test of combat and proving its worth. It is a story of honest technical assessment, transcending the propaganda and ideology of wartime. And it is a reminder that in the end, wars are won not by the most sophisticated weapons, but by the weapons that work when they are needed most, in the hands of the soldiers who depend on them, under conditions that test the limits of human endurance and mechanical reliability. The M1 Garand passed that test. The German engineers who examined it knew this. And their candid admission, preserved in fading documents from a fallen regime, stands as testimony to the triumph of practical engineering over theoretical ambition.